The study of extreme physics brought us the bomb. It has taken us inside the violent death of a star. And now, it has brought us face to face with the most destructive force in nature, a supermassive black hole. How large, how powerful can these monsters get? And what can they tell us about the extremes of time and space? The year was 1990. Hope for a new age of scientific discovery rose into orbit aboard the Hubble Space Telescope. A technical flaw in its optics, requiring astronauts to fly up to repair it, would delay, but not stop, this new age from dawning. In 1994, astronomers pointed the newly repaired Hubble at one of its most important targets, a giant elliptical galaxy 50 million light-years from Earth, called M87. Pushing deep into M87's core, they glimpsed a powerful jet of super-hot gas extending 5,000 light-years into space. With Hubble's remarkable resolving power, astronomers measured the speed of the gas racing around the center. They concluded the gravitational source driving these motions is a black hole, weighing in at 6.6 billion times the mass of our sun. News of M87 joined a flood of discoveries beaming down from Hubble's instruments. The public was captivated by strange and majestic shapes, captured from mysterious realms far beyond Earth. To scientists, Hubble was part of a quickly expanding arsenal of observing tools. A growing fleet of space observatories scanned the light of distant objects across the entire electromagnetic spectrum. On the ground, a new generation of giant telescopes with precision mirrors and dynamic optics allowed observers to look deep into the universe. Astronomers, used to long nights of painstaking camera exposures, were now awash in data streaming in from distant corners of the cosmos. A new vision of the universe emerged, one defined by vast energy releases, titanic collisions, mysterious new forces, and nature's strangest phenomenon, the black hole. Once thought of as mere curiosities, black holes have taken center stage in our understanding of the universe and how it came to be. A black hole begins its life in the brilliant light of a dying star. Within the folds of our galaxy, the energy let loose by supernovae stirs the celestial mix. Shockwaves from these explosions cause gas to condense, then ignite. Stars are born, sometimes hundreds at a time. Intense stellar winds from these newborn stars sculpt majestic castles of gas, the great nebulae long admired by astronomers. Yet, for the giant stars that set this process in motion, the consequences are grim. Back in the mid-1800s, mariners plied southern seas by the light of a brilliant star just off the plane of the galaxy in the constellation Carina. For over a decade, it was the second brightest star in the sky. Astronomers have been studying it intensively ever since. The star, named Eta Carinae, had undergone what's now known as the Great Eruption, an outburst that expelled two luminous lobes of gas that stretched some 12 trillion kilometers from end to end. Astronomers recently found that Eta Carinae is actually two giant stars closely orbiting one another. To explain the extreme turbulence of this scene, scientists modeled the fierce hot winds roaring out of these two companions. The orbital motions of the two stars allowed them to peg the larger one at 90 times the mass of the Sun. Eta Carinae is a supernova waiting to happen. In time, it will seize with convulsions, then collapse and explode. Some archaeologists believe this drawing depicts a supernova spotted by North American stargazers in the year 1054. The same event was also recorded in China, Korea, and the Middle East. In Europe, supernova sightings help dispel the prevailing belief that the heavens are static and unchanging. The astronomer Tycho Brahe saw one in the year 1572. "I was led into such perplexity by the unbelievability of the thing," he wrote, "that I began to doubt the faith of my own eyes." In modern times, astronomers have intensively studied the remnants of the 1054 explosion, the famous Crab Nebula. Waves of radiation roaring out of the explosion have etched circular patterns in the surrounding gas, seen here in radio, infrared, optical, ultraviolet, and X-ray light. You can see signs of a jet shooting out of the central region. This energy is coming from a tiny spinning object in the center, the size of a city. This neutron star is not made of any elements, but subatomic particles packed by gravity into an ultra-dense sphere. Physicists think of it as a single huge atom. It's roughly equivalent to packing Mount Everest into a sugar cube. Yet some dying stars meet a fate that is stranger still. In 1796, Pierre Simon, the Marquis de Laplace, imagined a breed of dark stars so heavy their gravity prevented any light from escaping. This idea, a head-scratcher,